Hey everyone, we are going to be covering absolute values in this module. So remember, the absolute value means a distance from 0, and distance cannot be negative, which is why when I take the absolute value of positive 5, I get 5, and when I take the absolute value of negative 5, I also get 5. So when we are talking about the absolute value of x is equal to a number, this means that we are going to be 3 units from 0. So I can go 3 in the positive direction and say that x is equal to 3. Or I can go 3 in the negative direction and say that x is equal to negative 3, which means we are looking at having 2 different solutions. So in a case like this, when I say the absolute value of x plus 13 is equal to 9, I'm going to leave what is in the absolute values the same, but I can either go 9 in the positive direction, so I set it equal to positive 9, or I can go 9 in the negative direction and set it equal to negative 9. Now we end up with 2 equations that we can solve. So I'm going to subtract 13 from both sides. And one of my answers is going to get that x is equal to negative 4. And then if I subtract 13 from this one, I end up with x equaling negative 22. So I want to make sure that these do in fact work. So I'm going to plug them back into our original equation to check them. So I have the absolute value of negative 4 plus 13 is equal to 9. And that is absolute value is 9 equals to 9, which is good. If I plug in negative 22, I get the absolute value of negative 9 is equal to 9, and that is also true, and both are good. If I have an equation where the absolute value is not by itself, the first thing we're going to do is isolate that absolute value. So I'm going to start by adding 1 to both sides, giving us that 3 times the absolute value of x plus 4 is equal to 12. And since I cannot distribute it into an absolute value, I do need to divide both sides by 3. And I get the absolute value of x plus 4 is equal to 4. Now that the absolute value is by itself, we can set up our 2 equations. So one tells me that x plus 4 is equal to positive 4, and then the other tells me that x plus 4 is equal to negative 4. So I can go ahead and solve by subtracting 4 from both sides. So this one is going to give me that x is equal to 0. And then if I subtract 4 from both sides for this one, I get that x is equal to negative 8. So to check my solution, I need to plug back into the original one. So I have 3 times the absolute value of 0 plus 4 minus 1 is equal to 11. So I have 3 times the absolute value of 4 minus 1. So the absolute value of positive 4 is 4. And 3 times 4 is 12 minus 1, which is 11, and that one's good. Now if I want to go ahead and check my other one, I have 3 times the absolute value of negative 8 plus 4 minus 1. Negative 8 minus 4 is negative 4. And when I take the absolute value of negative 4, it becomes positive. So this is really 3 times a positive 4 minus 1, or 12 minus 1 is equal to 11. And those are good. So now, in a case like this, the absolute value is by itself, but the absolute value is equal to a negative number. And we know that distance cannot be negative, which means this can never be true, and that there is no solution, because an absolute value cannot equal a negative number. If we have an example of absolute value equals absolute value, I'm going to keep the left expression the same for both of my equations. So I'm going to stay with x plus 7. And just like we did on the first one, we're going to use the positive case. So I have positive 2x minus 1. So it actually just stays the same. And then I will do the negative case. So I have negative and then the quantity 2x minus 1. Now we will solve like normal. So the positive case stays the same. So it's x plus 7 is equal to 2x minus 1. So I'm going to subtract x from both sides. I have 7 is equal to x minus 1. Add my 1 over, and I get that x is equal to 8. On the negative case, though, this is really negative 1 times this quantity, so I need to distribute in that negative. So I really get that x plus 7 is equal to negative 2x plus 1. Remembering to change the sign on both. So now I'm going to solve. I'm going to add 2x. and I have 3x plus 7 is equal to 1. Subtract my 7 over, and 3x is equal to negative 6. Divide by 3, and then x is equal to negative 2. So I can go in and check that both of these work. So I have the absolute value of 8 plus 7 is equal to the absolute value of 2 times 8 minus 1. So the absolute value of 15 is equal to, that's 16 minus 1, so that is also 15. That's good. And then when I plug in negative 2, I have the absolute value of negative 2 plus 7 is equal to the absolute value of 2 times negative 2 minus 1. So negative 2 plus 7 is going to give us 5. That would be negative 4 minus 1. So I get the absolute value of negative 5. And when I take the absolute value, those are both good. So our last problem on here, we're going to do the same type of thing. I'm going to keep what's in the absolute value the same. And then I'm going to use the positive and negative case. So my positive case would say that this is equal to a positive 4x. And then this one would say that it is equal to negative 4x. And now we can solve. So I'll subtract 2x from both sides. 12 is equal to 2x. Divide out 2. And we get a positive 6. Otherwise, I can subtract 2x on this one. And I get 12 is equal to negative 6x. Divide negative 6. And x is equal to negative 2. This is getting a little long, so I will show you the check on negative 2 because that's the one that actually causes a problem, but positive 6 is good. So when I go to check negative 2, I have 2 times negative 2 plus 12, and then 4 times negative 2. So this would become negative 4 plus 12, which is the absolute value of 8, is then equal to negative 8. But we know when I take an absolute value, it's always positive, which means this is not true. So negative 2 does not work for a solution, and our only answer is 6. All right, go ahead and work on the problems on the back.